In this video, we're going to take a hands-on look at slicing a data frame, or effectively pulling out specific columns and or rows that we want. A quick overview, and then we're going to jump right into an example. So, several ways that we can slice a data frame. One is we can just use the data frame and then square brackets and then specify a column name as a string that we want to extract from the data frame. And there's a shortcut too. If that column happens to be named without spaces or any special characters, we can use the data frame and then a period and then the column name that follows that. Now notice that the square brackets indicate we're selecting something, and so far we've passed in a single item. But if we want to pass in a list, we can do that as well. Note though that a list itself has square brackets, so we tend to get into this double square bracket syntax where you see the outer square bracket indicates we're selecting something from this data frame, and the inner square bracket is a list of the columns that we're selecting. Now we also have a few other tools, loc and iloc. So loc is typically used for labels, selecting by labels, and that could be either for the columns or the rows or even both. If we have an index where we're maybe using an object as the index type, this becomes very handy. We can use an integer index as well if we want, although loc we typically use for label indexes. If we're going to use an integer index, we'll typically use iloc instead. iloc will work with integers and will also work with a Boolean array. Boolean arrays where we have that, true, true, false, 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 true, true, and then it only returns to us those items that match with a true value. So let's take a look at a notebook. One I started in a previous video. I just loaded some CSV data. Now let's jump in and do some slicing of the data. Indeed, we have a fairly good sized data set for columns here. We have about 41, 42 columns and about 35 rows. And maybe that's a bit more than we can look at one go. So let's do a little slicing to select just a smaller number of columns. And we see now we get back a bit of a more concise data set with only the index, which is automatic, and then health center, address, and Monday close. Now that selection square bracket we see is very functional because we can pass in things like the columns that we want to view. But the neat thing is we can also pass in conditional statements where we say, okay, filter by this value. We only want to see this value. So one of the columns we have in the data set is pharmacy, and it indicates whether or not the health center has a pharmacy. So we can select only those that have a pharmacy. So in this case, you see we're starting with our clinicDF and the selection that we have, but inside the comparison is interesting because we go back to our clinicDF and say, okay, we want to get the rows where pharmacy equals yes, which effectively that's a Boolean expression, so if we see yes in pharmacy, it's going to be true. If not, it's going to be false. And that effectively builds up a Boolean mask that it can send to this clinicDF and say, okay, only show me the rows where it has a pharmacy. And if we take a look, scroll down to pharmacy, sure enough we see that the result are only the clinics that have a pharmacy. Now, here's a thought. I just did two different but similar things. Is there a way we can combine them? And the answer is yes. Let's start with that conditional that says, okay, return to me the rows that match this value. And since I haven't specified anything yet, it's going to return all columns. Well, what I can do is when I get that result back with the rows and all columns, I can say, okay, now give me just the columns. It's not a lot of typing, but it is something that's helpful to visualize because if we don't know what we're looking at, it can get a little bit confusing. Let's start with this filter that we have. Now let's go back up and grab the column selection from our earlier query. And now I simply put the column selection right after the filter. And why is that? Well, because up to this point, we received the result up here. And now what we're saying is, okay, given that result, give me only these three columns. And there we go. We have the three columns and only the clinics that have pharmacy. Now that we've mastered that, let's try our hand with iloc. When I say clinicDF iloc 2:4, it gives me this is a begin index, the first number, and the last number is an end index. So it says, okay, we are going to select, in this case, rows 2 to 4. But there's an important consideration here, and this is confusing in many programming languages, and that is, do we give you the second row, and do we give you the fourth row? Or do we not include one of those? Well, that's where these words inclusive and exclusive come in handy. Inclusive means we include that row. Exclusive means we don't include the row. One other consideration is, do we start counting with 0 or do we start counting with 1? Well, let's find the answer to both of these questions. So iloc 2.4, we see SBHC and dental for AWL, Academy of World Languages. So if I go up to our original data set, we see SBHC and dental are here. So, okay, so that would make SHBC, this one right here, the AWL, Academy of World Languages, that would make it the first row that we pick up. Okay, well, where is this then? We see there's 1 row, there's 2 rows, there's 3 rows, and the first reaction might be, well, that's the third row, so that first number must be exclusive. But as confusing as it is, no, it's not. What we have to remember is we start counting with 0. So if we start counting with 0, that's actually the second row. 0, 1, 2. So the first index is inclusive, which means we include row number 2. Then we have row number 3, which is dental. But notice that Academy of World Languages Visions was not included, and that's row number 4. So the net here, when we pass in 2, 4, the 2 is inclusive, the begin index is inclusive, the end index of 4 is exclusive, which means we do not count that in the result, and we start counting with 0. If any of that's confusing, number 1, I'm not terribly surprised. But what I recommend in any case, anytime you're doing an integer-based selection, just test it out a few times and make sure you're getting the results you want. And that's true in any programming language. That concept of inclusive and exclusive can be really confusing because it's not necessarily universally applied. Now, if I haven't confused you enough yet, I still have an opportunity to confuse you a bit more. And trust me, that's not my intention, but I know it happens. What happens if I take this selection that we started with, and what if I just add a bit more to it? First of all, let me change that colon to a comma. Second, I'm going to add a square bracket, encase this entire thing in square bracket, and I'm going to say colon, comma. So really, it just looks like I changed a few symbols, right? It can't be that big. So what does this give us? Well, notice, in this case, this gives us all of the rows and only 2 of the columns. And why is that? Well, the colon without a number beside it means give me everything. And if I have a square bracket, and I have a comma here, and then a list that follows, then it's basically going to say, okay, this must be the rows I want to select. And after the comma, must be the columns I want to select. And it gave me street name and city. So let's take a look up above, and I had 2, 4, right? So 0, 1, 2, 3, 4. It's a comma-separated list of the columns based on their column number. Remember, we start counting with 0. Now note I don't have a colon there because it's not a range, it's just a list of columns that I wish to select. Yeah, that can be a little confusing unless you really understand what each of these symbols means. Now, can we make it less confusing, or can we combine maybe our previous approach of column selection, which we did right up here, with the iloc? And the answer is yes, we can. So I select my columns, and that's going to say the result's only going to have these columns. Now I'm going to say iloc, and once again 2, 4. Now remember, if I have iloc without the whole comma sequence we had up above, it's going to assume, okay, this must be talking about rows. On the other hand, if I have something and then a comma and then something else, what follows the comma, it says, okay, you must be talking about columns now. So let's look at this hybrid approach that we put together. So health center address and Monday close, those are the 3 columns we've selected. And then iloc 2, 4, there we have the Academy of World Languages, SBHC, and Academy of World Languages Dental. So we used a little mix to get both the columns that we wanted and the rows that we wanted. And truth be told, I like this way a little bit better because it's more intuitive. We know exactly what we're going for here. We know these are the columns and we know these are the rows. Now let's try this again, but let's try it with our loc friend. And remember, loc, instead of using integer index numbers, tends to use names or labels instead. And that's a big reason in the previous video where I made this data frame, I read in CSV data and it gave me just a numerical set of row indices. I changed those to the health center code because that's words. And a neat thing about loc is it allows us to choose words in a range. So I start with my normal selection here to say, okay, here are the columns that I want. And following that, I simply say .loc, and then I pass in the name from the index column, the names that I wish to include, basically the range that I wish to include. So I'm going to say CCPC Millvale, and then a colon. Note the colon means a range. And then CCPC North Side. Let's see what we get. So notice we get only the columns we selected, Health Center, Address, and Monday Close. But for the rows, note that we get Millvale, Millvale Dental, Mount Airy SBHC, and then North Side. So it gave us these two items and everything that's between the two items. As a matter of fact, if we wanted to expand this a little bit, I could say CCPC AWL SBHC. You see that's going to give us a significantly longer list because we're starting way towards the top and we're going all the way down to North Side. So selection of the columns and selection of the rows. It's important to read carefully though because notice where the loc is. We can attach the loc directly to the data frame, and if we don't notice it's attached directly to the data frame, we might not be expecting a little bit different behavior. Let's try a few scenarios here. So a few differences here. First of all, I've replaced the colon with comma, so I'm saying select from this list, not necessarily select a range start to end. But also notice, of course, we've put the loc right next to the data frame. Notice that we now have the columns, or sorry, we have the rows first, and we have the columns second. Where up above it was the opposite, we had the columns first and then the rows, but that's based on the position of the loc. So just be very careful when looking at the syntax. It can get really easy for that to be confusing. If you might think, well, having a loc over there is a little bit different, but it can get confusing very quickly. Once again, we can take these rows, and instead of having a list, we can simply put a colon, which means, okay, give me all rows, and all rows with only the columns that are specified here. Okay. So here's some more interesting things we can look at. We know that clinicDF, Health Center Address, Monday Close, as we see, that will give us just a certain number of columns. But what if I say clinicDF, and then square bracket, which is our selection naturally, and then colon, and then a number like 2. Notice that it's giving us all columns back, but only 2 rows. And what that is saying is effectively give me anything up to, but not including 2. Now, so 0 and 1. Now, what if I say 2 colon? That says give me 2 and everything thereafter. So we see here, we get all of the rows. Where in the previous example, we get all the rows starting with 2 and going thereafter, where before we only got 2 rows. Now, so what you notice here is that the colon is kind of like a way of separating the begin index and the end index. And if we have a number and then a colon, it says start here and give me everything afterwards. If we have a colon and then a number, it says give me everything up to, but not including this point. Now we can combine these two things together and say, okay, give me a low range, or give me the low end of the range and the high end of the range, and give me everything in between. So if I say, for example, 2 colon 5, this probably is going to look a little bit familiar because it's going to give us what's at row 2, what's at row 3, and what's at row 4, but not row 5 because row 5 is exclusive. The end index is exclusive where the begin index is inclusive. And once again, remember, we start counting with 0. Now, can we combine this row selection with column selection? And the answer is yeah, we can, because basically anytime we get a data frame back from an expression, we can select columns from it. And you see that even though this one's returning to us a subset of the rows, it's still returning to us a legitimate data frame. So I can say clinicDF.25, and now I can say Monday close. And we see that it gives us only the Monday close column for these 3 rows. And naturally, going all the way back to where we started, we can come back and say, okay, just give me all rows by saying I specifically want just that Monday close column. Or even I could do it with dot notation and get the same result. The nice thing is, number one, this wraps up our introduction of slicing with several different approaches, slicing a data frame. But this also sets us up really well for the next video we're going to have, which is slicing a string and pulling data out of a string, creating a new column out of it, changing the data type of that string or that object, and then using that object to do some filtering. So a lot more fun to happen, and I look forward to seeing you in the next video. Thank you.